Hey guys, this is Om and welcome to Civil Raja, your gateway to future. So guys, in this session, we are going to talk about a structural design. So basically, the structural design of RCC building, which is reinforced concrete building, involves the process of determining the configuration, dimension, and specification of buildings' structural elements to ensure that they can safely and efficiently support the applied loads. Now, there are two terms that are important for us. So one is the structural elements. So what are the different structural elements in the building? So the beam, column, slab, footing. These are the four structural elements in the building. And then there is the fifth structural element, that is staircase. So these are the five structural elements. And while doing the structural design, we need to ensure the dimension and a specification of these structural elements. Now, we have to ensure that they can safely and efficiently support the applied loads. So what are the different applied loads on the building? So basically those are dead load, live load, a seismic load. In some areas, the wind load is also considered, and the areas where we have the snowfall, there we also consider the snow load. And then we go for the load combinations. So in order to design a structure, we have to understand that all these loads and their load combinations can be taken or beared by the building easily. Okay. Now, here is a general overview of the steps involved in the structural design of a RCC building. So what are the different steps? First is the architectural planning. Understanding the architectural requirement and constraints is the first step. Then we have to establish the layout, size, and shape of the building. Then comes the second step is the load analysis. We have to determine the various loads on the structure that will be subjected to, such as dead load. Permanent loads like the weights of the structure are called dead loads. Live loads, which are the temporary loads from the occupants and furnitures. Then there is wind load, earthquake load, etc. Like the snow loads and the load combination. These are the something which comes in, etc. Now, third step is selection of a structural system. So we have to choose an appropriate structural system based on the building's requirement and load combination. Common systems include the frames, shear walls, and slabs. So I think you already know what is a framed structure. So what is frame, that is clear to you. Now, the another structural element is shear walls, which is not applied in all the residential buildings. So it is basically in the buildings where we have to create the basements. Then we have our slabs as the structural element. Then comes the fourth step, which is structural modeling. So in this step, we have to create a three-dimensional, that is 3D computer model of the structure using the structural analysis software. This model includes all the structural elements like the columns, beams, slabs, and foundation. Now, what are the different structural analysis software that we use nowadays? So these are STAAD Pro, ETABS, and Tekla Structural Designer. There are many more, but these three are widely used. Now comes the fifth step, which is structural analysis. In this step, we perform the structural analysis to evaluate how the building will respond to the various loads. This analysis ensures that the structure meets safety and performance criteria. Now, the sixth step is member sizing. In this step, we determine the appropriate size of the individual structural members like the columns, beams, and slabs based on the analysis results, considering factors like the bending moment, shear forces, and axial loads. I hope you are already knowing all these things like what is bending moment, what is shear force, what is axial loads. So I hope you understood all this. If you haven't understood, then you can just let me know. I will make a separate videos on these loads. Then comes the reinforcement design. So our seventh step is reinforcement design. In this one, we will design the reinforcement details for each structural element to enhance their strength and ductility. This involves determining the shaping, determining the spacing, diameter, and configuration of reinforcing bars. So whenever we have to provide a reinforcement, what we consider over there, what should be the spacing between the two reinforcement? That is the two different reinforcing bars, and then what diameter of the bar should be there, and then the configuration. Okay. Now comes the eighth step, which is foundation design. Designing the foundation to transmit the load from the superstructure to underlying soil. This may involve the design of the footing, piles, and other foundation types. So there are various foundation types. I hope you know that there is a pile foundation, then there is a simple footing, which is isolated footing, pad footing, sloped footing is there. Then there is another type of foundation, which is a mat or raft foundation. Okay, so these things comes under the foundation design. Then comes the seismic design, if applicable. Why if applicable? Because we do not need to it is not mandatory to go for the seismic design in zone 2 and zone 3. But yeah, in zone 4 and zone 5, it is highly recommended to go for the seismic design, because the seismic load is dominant is zone 3, zone 4 and zone 5. Okay, there is no more zone 1 in the seismic zone. Okay, so we do not include that. Zone 2, 3, 4, 5. These are the 4 zones available in India. Okay. So if the building is located in seismic zones, additional considerations are made to ensure that it can withstand seismic forces. This includes detailing a special seismic resistant element. Okay. So now, there is one more thing. I just said that in zone 2 and zone 3, we do not need to consider the seismic load, but this is just for the regular structures. If your structure is irregular, then you have to consider the seismic forces. And anyway, there is different zonal factor for the seismic for zone 2 and 3 also. So we definitely include those loads. If you are using the wind load in zone 2 and zone 3, then there is no need to go for the seismic load. Otherwise, you will have to go for seismic design also. Now comes the code compliance. Ensuring the design adheres to the local building codes and standards, which may vary by region. Now comes the last point, which is construction documents. Preparing detailed construction document, including the drawings and specifications to guide the actual construction of the building. So what are the different steps? First is the architectural planning. Second is the load analysis. Third is the selection of the structural system. Fourth is structural modeling. Fifth is structural analysis. Then sixth is member sizing. Seventh is reinforcement design. Eighth is foundation design. Ninth is seismic design. And the 10th is code compliance. And finally, we have to go for the last step, which is our 11th step, that is construction documents. The most important one. Preparing the detailed construction document includes drawings and specifications to guide the actual construction of the building. Okay, so these are the 11 steps that you have to follow. And it's important to note that the design process involves iterative steps, and adjustments may be made as the design progresses. So it's not like if you have chosen a column of, let's say, 250 by 250 mm, so you have to stick with 250 by 250. It's not like that. It may fail, it may pass. If it is passing, then it's good. If it is failing, then you will have to increase the size. So there are different things. So same happens with the beams, and you can say in some cases it happens with the slabs also. So it is a iterative process. That means you will have to change the size, you will have to check it again, like if it is passing or not. Then additionally, the involvement of qualified structural engineers and compliance with the local building codes are crucial for ensuring the safety and structural integrity of the building. So you are going to be one of the structural engineer. So be qualified so that no building collapses which is designed by you. So guys, that's all about the structural design, and we will meet in the next session for the role of a structural engineer. Till then, keep learning. Thank you guys.